Okay, so this is the one that we're going to go over in class, but just in case you missed it or need to see it again. An Acrobat has a mass of 50 kilograms, okay, and we're trying to draw a quantitative force diagram for the Acrobat, okay? So quantitative, why do none of these colors work? Okay, quantitative, remember, means with numbers, okay? So these need to have numbers on them, okay? So interaction diagram, I'm going to have the Acrobat, the stool, the ground, and the earth. Okay, I could put the other stool over here, right? But see, it's not even involved in anything, so I probably wouldn't even bother with it. Okay, all right, the Acrobat and the stool, that's like resting on a surface, so that's going to be a normal. Okay, stool and ground, that's also a surface, so that's going to be a normal. Okay, and then everybody's going to get a gravity. Okay, gravity for the stool, and again, gravity for the ground if you so desire it. Okay, all right, I'm looking to do a diagram of the Acrobat. Okay, so I can see that the Acrobat has two forces, two interactions, the normal and the gravity. Okay, so I'm always going to start with the gravity because it's always there and it always points down. Okay, gravity only points down. That's with the Earth. So that's going to be FG. Feeler is the Acrobat. Dealer is the Earth. Okay, and I'm going to need a number for that. All right. And now I need to draw the normal force, okay? But first I need to think about what's happening here. And since the Acrobat, I assume, is not moving, just kind of doing this handstand, then I would say that the forces are balanced, okay? All right, so I know that my upward force of normal on the Acrobat from the stool is going to have to equal the force of gravity, okay? That actually doesn't look so good, does it? Let me erase that. It's going to be slightly longer, okay? All right, so now I need the numbers. And this time, notice it's not telling me the weight or the force of gravity of the Acrobat. It's giving me the Acrobat's mass, okay? So from the lab, we found out that the force of gravity equals the mass times little g, which is that slope number that we got, 10 newtons per kilogram. Okay, so I'm going to have 50 kilograms of mass times 10 newtons per kilogram. That's the little g that we got from the lab. That's going to cancel. And so I'm going to get 500 newtons. Okay, so in effect, what you're doing, right, basically is if you're given the mass, you're multiplying by 10 to find out the weight. Okay, so that's going to be 500 newtons. So in turn, oops, this has to be 500 newtons also. Oh, yeah, Acrobat, so that's right. Okay, all right, so there goes the first one.